So when you find antiderivatives, you get an infinite number of them because of that constant that could be added at the end. In this video, we're going to see how we can nail down a particular constant in a particular situation using what are called initial conditions. So let's jump right into an example where we want to determine a function, let's say f of t. So determine f of t if f prime of t equals t plus 1 over t to the third power. And we have this other condition that f of 1 equals 6. And so this is what we call an initial condition. This helps us determine that, okay, we're going to anti-differentiate this f prime to get f of t, which is going to have a plus a c at the end, some constant. But if we know that the original function, if we evaluate it at the input 1, and that gives us an output of 6, that's going to help us determine what constant value we have to pick in order for this initial condition to be true. So let's see how the mathematics plays out. The first thing I'm going to do is I need to anti-differentiate f prime of t, and that's going to help me figure out f of t. So f of t is the antiderivative of f prime of t with respect to t in this case. Maybe we're so used to writing dx, but it can be with respect to t, and it is in this case. So now I'm going to anti-differentiate t plus t to the negative third with respect to t. And what I get is 1/2 t squared minus 1/2 t to the negative second plus a constant c, assuming you're pretty comfortable with antiderivatives here, okay? So this is what we get for f of t. But now we have to implement our initial condition that f of 1 equals 6. So this, remember, is f of t. So if f of 1 equals 6, then that means f of 1 is all of this. So f of 1 means plug 1 into the f of t function, which is 1/2 times 1 squared minus 1/2 times 1 to the negative second plus c. That's f of 1 equals 6. And you can see what happens when we're able to plug in an input to that function. The only unknown is the constant c, and now we can use basic algebra to solve for that. So what we get is 1/2 times 1 is 1/2, minus 1/2 times 1 is 1/2. So these guys subtract and just go to 0. So in fact, this one's very simple. That constant is 6. So the final answer is, what we're trying to do is determine f of t given this information. So the particular antiderivative that we're looking for is this guy where c is 6. So here, this is our most general antiderivative. And then here is a particular antiderivative. This particular antiderivative is a member of this family, but this is the only antiderivative that satisfies this initial condition. This can be useful in applications where you want to know what antiderivative applies at a particular moment in time, for example. Okay? Let's do another example here. Okay, so let's determine, we're changing variables again because you want to start getting comfortable with the notation. Determine f of theta, so now our independent variable is theta, if f prime of theta equals -3 over the square root of 1 minus theta squared, and f of the input square root of 3 over 2 equals pi. So now we have another, we're given the derivative and an initial condition, and we want to find the original function. So we're going to start by saying that f of theta equals the antiderivative of f prime, which is this function, -3 over the square root of 1 minus theta squared, d theta now, because our independent variable is theta. And hopefully you recognize, ignoring the coefficient of -3, this is like 1 over the square root of 1 minus something squared. That is, in fact, so I'll keep my -3 coefficient. The antiderivative of this guy is the sine inverse function with the argument of theta. And you can verify this through differentiation. If you differentiate this, you'll get this function back, and we have to build in our constant. So we have the general antiderivative of f prime, the general f of theta function, but we want to find f of theta by utilizing this initial condition. So now, f of square root of 3 over 2 means plug, remember that this is f of theta. This is the formula for the f function. So if I want f of the square root of 3 over 2, then I have to plug the square root of 3 over 2 into this function. So this guy tells me -3 times the sine inverse of the square root of 3 over 2 plus a constant, that has to equal pi. And so now I have to solve for this constant c. Well, the sine inverse of square root of 3 over 2, when I'm looking at this, I'm looking in the first quadrant where the vertical side is square root of 3 over 2. So this reference angle is 60 degrees, or pi over 3. So this turns into -3 times pi over 3 plus c equals pi. And simplifying this, I get -pi plus c equals pi. And then adding pi over tells me that c is 2 pi. So now I know the particular constant in this general antiderivative that satisfies these conditions. So my final answer is that f of theta, the function we're looking for, is that guy, -3 times the sine inverse of theta, plus the constant 2 pi. And if you check this, again, differentiate this, you should get this derivative function. And this constant helps us satisfy this initial condition. Okay, so that's good practice with antiderivative using an inverse trig function, as well as finding a constant using an initial condition. We'll do one more example. So now we're going to be given a second derivative. So let's determine f of x. Determine f of x if f double prime of x equals 8x cubed plus 5. So that's our second derivative. And we have two initial conditions. F of 1 equals 0 and f prime of 1 equals 8. So same principle, except now I have to go from f double prime to f. I have to anti-differentiate twice, yielding two constants. So let's get down to it. I'm going to start with f double prime and anti-differentiate to get f prime. So I need the antiderivative of 8x cubed plus 5 with respect to x in this case. So increasing my power to 4 dividing by 4, I get 2x to the 4th plus 5x plus a constant c. Okay? So this is my f prime function. And I can look at my initial conditions, and I can see that I have an initial condition not just on f, but also on f prime. So it might be a wise idea to go ahead and work here to figure out what this c is using that initial condition for f prime. So f prime of 1 equals 8. Well, f prime of 1 means plug 1 into the f prime formula. So I get 2, let's write it out, 2 times 1 to the 4th plus 5 times 1 plus c has to equal 8. And so simplifying this down, this all just turns into 7 plus c equals 8. So c is 1. So I know now that f prime of x, the first derivative, is 2x to the 4th plus 5x plus 1. Okay, so that's my first derivative function. Now I need to figure out f of x through the process of antidifferentiating f prime. So f of x equals the antiderivative of 2x to the 4th plus 5x plus 1 with respect to x, which gives me 2/5 x to the 5th plus 5/2 x to the 2nd plus 1x, or just x, plus a new constant c. And since I've determined the previous c, I've kind of disposed of it so I can reuse the same letter here. All right? And then I need to use the initial condition about f to figure out this c. So I know that f of 1 equals 0, and this is my f formula here. Now, you can write it all out if you want, but plugging 1 in is simple. So I just get 2/5 times 1 plus 5/2 times 1 plus 1 plus c all has to equal 0. Now I'm going to solve for c. So getting a common denominator here, I'll multiply top and bottom by 5. So I get 10/25 plus 25, let's see, no, sorry, multiplying top and bottom by 2. So I get 4/10 plus 25/10, that's 29/10 between those two. Plus 10/10 is 39/10. Plus c equals 0, and subtracting over, I get c equals negative 39/10. So the final answer is f of x is this function, but c is negative 39/10. So f of x equals 2/5 x to the 5th plus 5/2 x squared plus x minus 39/10. So I want to do an example where we had to work from the second derivative with two initial conditions to determine our function, and there it is. We also got to practice a little bit with the antiderivatives using the inverse trig functions. And so this is just all great practice with antiderivatives in addition to these initial conditions to nail down a particular antiderivative.